Welcome everyone. Another one of these webinars. This one we're really excited. Alex and myself will be presenting the CSI commercial inverters. Specifically, there will be a focus on the 600-volt AC solution for Canadian rooftops. So we're really excited about this. It's been quite a popular product for us. And yeah, we'll get started with it. So let's see. Okay, so first off, why did we select this inverter? So our mission is to assist solar installers in Canada to design high quality and competitively priced solar projects for every home and commercial building in Canada. So this is a solution that we thought fits in really well because specifically for the Canadian market, as it is a 600-volt solution, and it is quite competitively priced as well, right? So this was a natural fit ever since we no longer had access to Huawei products and the very popular 45 KTL. There was a really big demand for a 600-volt solution in this market, and we've looked at a number of different options from different manufacturers, and this is kind of what we landed on. So the reason why this inverter is just multifold. First of all, Canadian Solar is a leading manufacturer of solar equipment. It was founded in Ontario back in 2001, has globally over 13,000 employees, and it's got a local presence in over 20 countries. For Canada, they are based out of Guelph. I think that's where it all started. So they have a manufacturing facility there where they're still producing some solar modules. There's local support for their inverter side with tech service located in California. Obviously, most companies and even individuals that are kind of dabbling into the solar industry are familiar with the brand, which is a really important thing when a solar installer developer sells a project. And the warranty is really, really good. They're listed on Bloomberg Tier 1. And they've been traded on the NASDAQ since 2006. Looks like, I'll just see if there's a question there. Oh, there's already a bunch of questions. We'll get to that after my part is done here. Okay, so then why Frankensolar? Well, we have already over 60 megawatts of these inverters ordered for this year. And of that, about 37 megawatts have been sold already. With a proven track record in commercial inverter sales. Specifically, we are the #1 commercial string inverter seller in Canada by quite a long margin. I'm pretty positive on that. We're really, really strong in it. And part of that is the next point. We've got in-house electrical engineer, Alexander Wolf. Alex, just going to quickly jump to you. Can you tell us a little bit about your history, how you got into what you're doing now?
For sure. I started electrical engineering with a focus on power electronics, and then I ended up at a German inverter manufacturer into hardware development for three-phase inverters. And that job initially brought me to Canada, and I became a product manager for a very large American inverter manufacturer before I joined Frankensolar.
Yeah, and then you joined Frankensolar, and obviously that's really when things took off for us on the inverter side of things. We've always been good at it, but like definitely brought us to the next level. With that, we have also very knowledgeable sales staff. So we also got, for example, Marty Fleet on our team. He was part of Advanced Energy back in the day, selling inverters for them. Having sold multi 100 megawatts worth of inverters in Canada. So and in general, we pride ourselves in having a really well versed sales team. We also have an approved D-rating service. Nobody in Canada has even remotely D-rated as many inverters as we have. There's well north of 1,000 inverters that have been D-rated at Frankensolar over the last 5 years. And what you'll get from us is unbiased support. So yes, this presentation is about Canadian solar inverters. However, we pride ourselves in helping you pick the right inverter for your solution. A lot of times this will be this Canadian solar inverter. Not always, of course, and we will tell you if it's not the right product for you, right? So there's a variety of different products that we carry, and we will help you choose the right product. Okay, just a quick global presence. As you can see here, all the countries that Canadian Solar is based in. So we got obviously the United States, Canada, South America, Europe, Asia, Africa, Australia, pretty much anywhere. All the major markets, they have a local presence in. And then the bankability report from Bloomberg, for 4 consecutive years now, they have been at the top 100% approval for bankability, which is a huge thing when we're talking about picking an inverter for a 25-year lifespan of a project. Okay, so there's 3 platforms for the commercial inverters right now. So there's a 480 volt solution that is a 100 kilowatt unit. Those are really ideal for 480 volt connections, which we don't have a whole bunch in Canada for commercial projects. There definitely are some, and this will be the right product for you. We do also stock those. Currently, we're sold out on those, unfortunately, but there will be more stock coming in the summer, early summer on that. Then there is the large commercial unit, which is the 600 volt solution. It comes in, it's the 125, which is really a 137.5 kilowatt inverter, and there's a 185 kilowatt inverter. And that's really what we're going to be focusing on. This product is ideal, and what we've sold most of in the Canadian market is 600 volt AC, 1500 volt DC. It has AFCI, really everything you will need for your commercial rooftop installations, or ground mount. It will work on ground mount as well, of course. And then there's a large utility string inverter, which is a 255 kilowatt, 800 volt AC inverter. And this is really a good solution for utility type projects. It is 800 volt AC, which makes it a little bit more difficult to get AC equipment such as disconnects and things like that. So unless you have a very large project, we don't recommend this product as you need custom made AC infrastructure for this, which will be difficult to get. Excuse me. Okay, Alex, please take over.
Thank you very much, Danny, for the quick introduction. As Danny said, we want to focus on the 600 volt product today in the 137.5 and the 185. And in this presentation, we want to go from start to finish through the inverter. You see here the presentation overview. We want to talk about DC specification, the surge protection oversizing on the DC side, then the AC specification, how it's being connected to the electrical grid, the thermal performance of such a very high-powered AC unit, the mechanical insulation and limitations of how it's being typically installed in the field. Very special and very important for the Canadian market, changing certification requirements and how the inverter is compliant with that. Smart grid features that are also related to that new certification. How the system in the field will communicate to your SCADA or your monitoring system. Documentation requirements, what is all there to make your life easy with your engineering company. And then at the end, we talk about maintenance, what you typically should do with such a high power product, and how we can use it on commercial rooftop when it comes to rapid shutdown and rapid shutdown requirements.
Sorry if I quickly jump in. There was one question from Lewis who's asking about the 75 to 90 kilowatt inverters at 480, and we are not planning to carry those. For us, we want to streamline things, and that's why we're going to carry the 100 kilowatt unit. We can, of course, derate those units, and that's much more efficient for us and in an extension for you, because it will mean that we have to have less margin on the product and just can roll through stock more easily that way. Sorry, Alex, continue.
And maybe to add to that, optimizing lead times. That's a very, very big topic these days, because the lead times of those inverters, or in general, high-powered inverters these days, is very, very long compared to past. Okay, Danny, next page. Starting with the DC specification. So these inverters, compared to what conventional inverters were in the past, are now multi-MPP tracker inverters. So the 125K or 185K or even the 255, all of them have multiple MPP trackers. The 125K unit has 9 MPP trackers, and the design is in a way that you always have 2 strings per MPP tracker. The reason for that is where many companies go this route due to the fact that you don't need fusing for 2 strings in parallel. And by having multiple separate MPP trackers, they are galvanically separated. You don't have any short circuit current or current flowing backwards from other strings connected to a different MPP tracker. So in this case, the smaller unit has 9, so 18 strings effectively, and the larger unit, the 185 and 255, is going up to 12 MPP trackers, 24 string inputs. A very important feature these days for specifically high current modules or even bifacial modules that are even higher current at that point is that the inverter, when the MPP tracker has a very high short circuit current limit. In this case, per MPP tracker, the Canadian solar inverter has 50 amps. And 50 amps typically is plenty of capacity to even accommodate a 600 watts and higher bifacial module, 2 strings parallel per MPP tracker. Very important as well, especially in the Canadian market, having a connector that is a standard connector. And Stoibli with the MC4 connector is pretty much the industry standard when it comes to solar connectors. The CSI inverters use genuine Stoibli MC4 Evo 2. The Evo 2 is the 2nd generation of the MC4 connector that are also rated to 50 amps. So you can go into the field, and if you like, you can pre-combine strings in the field and have only 2 conductor home run, 1 positive, 1 negative to each MPP tracker, or you can run it conventionally that you run 2 positives, 2 negatives to each MPP tracker and do not combine in the field. The current MC4, and I assume pretty much everyone in the industry is aware of that, conventional old MC4 connector is officially compatible to the Evo 2. So you can use Evo 2 with MC4 connectors, the conventional ones, in one system, and you can mate them together, and that's CSA approved. Exactly. The inverter comes with a set of 48 connectors for the big ones and 36 connectors for the smaller inverter. So you don't have to buy additional connectors when you are in the field and installing these inverters. Every inverter has 5 or 6 DC disconnect switches. The number of MPP trackers is directly then coupled through the number of DC switches. Since we have now these large inverters, we also have a much larger number of DC switches for that unit. The AC output, you see all the way on the right, is its own cabinet. So you can open it up. It's a little a hinged lid that can be opened, and it's very easily accessible on the site. So the inverter does not have to be opened. The lid can stay on, and you just wire it up with the field crimped connectors on the bottom, and the AC side will go to the terminals on the right side. Page, Danny. On the input side, as with most 1,500 volt inverters, you try to have a string design that is as long as possible, so as many panels in a row as possible to achieve as high as possible voltage. In the Canadian climate, we have both extremes. We have very, very low temperatures in the winter, and we have relatively high temperatures in the summer, depending on where you are in the country. So a very common string design is somewhere between 22 and 26 modules on the high side, and that works for pretty much almost all climate zones in Canada. The inverter has full output power, and that's the green zone I have marked in that, from about 860 volts on the low end to about 1300 volts on the high end. And if you do design your system efficiently, so long strings, you will always operate in that sweet spot where you are not affected by curtailment on the bottom, where the inverter might not be able to provide full nameplate output power if you design your strings with a too low DC voltage. The inverter can actually start already at 570, which is quite low compared to other inverters on the market. But again, try to really utilize that high voltage string design, because that leads to a smaller number of strings and therefore cost savings in your entire design. Very important with these large units, since we now transition from a combiner box, like previously installed with a, let's say, 150 kilowatt string inverter with a single input that typically had over voltage protection in that combiner box. Now the over voltage protection is built into the inverter itself, and it's available on the AC side, so on the output of the inverter, as well as on each of the inputs of the inverter. The metal oxide resistors that are being used here are type 2. And they have a rating on the AC side of 15 or 25 kiloamps, and on the DC side, they even go up to 20 or 40 kiloamps. So they're very capable overvoltage protectors that are already built in and come with the inverter. No additional parts need to be purchased, ready to go for that application, which is very, very nice for such an inverter concept. We are preaching DC to AC oversizing and high DC ratios for many, many years now. And we want to just have two examples here what you can do with the inverter. And we have picked the smallest inverter in that category. That's the 125K, which is technically a 137.5. And we will talk about that a little bit later. If you pick a random 72 cell panel these days, we are typically using 550 watts. And if you have a string design that works in most climate zones in Canada, 25 panels per string, and 18 panels, so 9 OVP trackers, 2 strings each, then you can get up to about 247, let's round it up to 250 kilowatts on the DC side. And if we divide that by the 137.5 kilowatts on the output the inverter can do on its highest setting, then you have already here a 1.8 to 1 DC to AC ratio, which is more than capable for most common DC to AC ratios. We see a lot of DC to AC ratios in real life that are in the 1.3, 1.4, 1.5 range. And specific projects, when you are, for example, capacity restricted by utility company and you're only allocated a certain, let's say 500 kilowatts capacity, then you can utilize that high DC to AC ratio to optimize the customer system. And you can also use that to optimize the financials for your end customer that owns the system to really achieve the lowest cost per kilowatt hour. The limitation on the CSI inverter, as we discussed earlier, is the up to 50 amps on the MPP tracker from your panels. That has to be always be done. And of course, like any other inverter, there's a 1,500 volt limit. In this case, since it is a 1,500 volt inverter, you should always string your strings to not exceed that voltage limit.
There was a quick question from Shamor about inverter derating and if it could be derated to 100 kilowatts.
Exactly.
Are you covering derating later in the presentation, or do you want to quickly talk about it now?
That would be a next half sentence to the second example. So what you can do, instead of leaving the inverter at its nameplate capacity rating, we can pretty much adjust the power of the inverter, and you can use that for a multitude of applications. One here in the example is if you want to have higher DC to AC ratios, you can just lower the AC. The DC stays the same, so you would achieve higher ratios, obviously. But you can do the same thing for if your utility company gives you 100 kilowatt contract capacity, you can be compliant by reducing the output power to 100 kilowatt. And yes, that is actually a very common thing to design it to and limit it to 100 kilowatts, because in other jurisdictions, there are different capacity limits. BC is one of them, where 100 kilowatt would be a very good building block. Next. Going right to the AC specifications, since we're talking about the 600 volt inverter, the 600 volt inverter natively is a 185 kilowatt device when it comes to the actual hardware and the output stage, so the topology of the inverter. If we go to the smaller unit, it's hardware-wise the exact same thing, with the only difference that it has only 9 instead of 12 OVP trackers. But from the actual inverter hardware on the output stage, it's exactly identical, which means that what CSI was doing, they were derating the inverter from the factory, more or less, to have a 125K, and that 125K has an actual output power of 137.5. That's a little bit misleading sometimes because they choose these two different numbers. And that has something to do with the power factor a lot of people use. The Canadian market most of the time has still a power factor of 1. A lot of other jurisdictions already have requirements that you have to have a certain fixed power factor of, for example, 0.9 or even all the way down to 0.8. And the PQ diagram you see here for the 185 allows the to provide a certain apparent power and reactive power 80 to the maximum 111 kVAR here, which means that you are reducing the active power component on the 185. With the 125K, which is technically a 137.5 kVA inverter, you can still have 125 kilowatts on the active power output. And at the same time, you can provide a power factor of 0.9. Then the total system will be in the range of 137 kVA, but you maintain that 125 kilowatt active output power. So depending on where you install your system, if you do have a power factor of 1, you will get the full power of the 137.5. If you don't want that, we can derate the unit for you that you have a true 125 kW, 125 kVA unit if you want to have that nice 125 kilowatt building block. I think that answers the question.
And Shamor was asking about SunSpec. So the 100 kilowatt unit, that's the 480 volt solution. That one we carry in a SunSpec. However, the 125 and 185 and the 255 are not SunSpec certified. So what you would need if you wanted to use AP Smart shutdowns, for example, would be the transmitter kit from APS that can be then installed in the inverter. It's not a problem. It's fairly easy. And we can definitely help you out with that if you want to go and install APS shutdowns. Alex will talk a little bit more about rapid shutdown later on in the presentation.
We have a slide for that, exactly.
Sorry, there was another question from David Bosch about a power factor improvement. Is anything possible there?
So there are certain functions, and that's exactly on the right side of the slide here. So we have reactive power options. The most common option is a fixed power factor, like a 0.9 power factor. We can also do power factor off power, so a power factor depending on the power curve. What it cannot do, and that's one of the questions, it cannot do reactive power at night with the current firmware version. There are other inverter products that can do that. This specific inverter can only provide the reactive power component when the inverter is actually running. Yeah.
There was a question about copy of the slides. So we will post, just like all our presentations, all of those are posted on YouTube. So you can go back and revisit those afterwards. Also, if you, I was going to say this at the end, but if anyone wants to have a more in detail look about all this stuff with the rest of their team, because I assume not everyone from everyone's team is here present, Alex and I are happy to go and do a private session with your company and answer any and all of the questions that you may have. Yeah, Alex, next slide or?
Yep. Switching right to the electrical installation. So the unit is a true 3-wire, 3-phase inverter. It does not have a neutral reference. It does not have a terminal for a neutral. So you can install them in a multitude of transformer configurations. Very typical configurations, since it is a native 600 volt inverter, is to the building's 600 volt supply, which in pretty much all of the cases is a Y configuration on the transformer lower side. You can also use the inverter in a delta configuration if you have a larger ground mount, for example, and the system is a delta-delta on the high voltage transformer. The only thing that is not possible, according to CSI, you cannot use a Y connection on the high voltage side with a delta connection on the low voltage. That is not supported with that inverter. As long as you have a Y connection on the high side and a Y connection on the low side, as the first three examples in the diagram, that is perfectly fine in that system.
Lewis was asking about derating and if this is something that can be done in the field or if they would have to contact Canadian Solar or what the process is.
So derating is done for the Canadian market in our location here in Brampton, Ontario. If you need a derated inverter, ideally specify it with your salesperson that you want to have it derated to XYZ kilowatts, and we can do that in-house, and then we will send already a derated inverter with the documentation and the additional label on the unit to you and your installation location. But it's not a field deratable service. Exactly.
And like I mentioned at the beginning of the presentation, we've done well over thousands derating of different types of inverters. Pretty much any inverter we carry, we have derated in the past, and we've never had any issues, and we've always been authorized by the manufacturer to do that.
When it comes to AC connection at that high power level, conductor sizes are definitely much, much larger compared to smaller units. So most customers are using aluminum conductors for that. The device and the terminal support aluminum. If you use typically a dual rated luck, like in the picture here, they're available from multiple manufacturers. That is then the transitional luck to the M12 standoffs that you have in the inverter connection cabinet that is on the right side of the unit. You can also use specific crimp-on ring lucks, but most installers typically use the mechanical lucks that are very common. ACWU, so the tech cable standard in aluminum at 600 volt rated is probably the lowest cost option to get that system electrically installed. Conductor sizes typically range from 4 aught to 250 kc mil due to the relatively high output current these units have. The breaker sizing and the overcurrent protection for the small unit, so the 137.5, is typically a 175 amp unit, but you can use overcurrent protection up to 250 amps. So a standard 250 amp category breaker, if you use a breaker panel, would be perfect for both the 125K or the 185K. Very important when we talk about output power for these high power units is how much power they can produce at a certain temperature, ambient temperature level. The operation range for the unit itself is similar to most inverters that are on the market, starting at -25 C for the low voltage, low temperature operation, up to about 30, 40, 50 degrees. The high temperature operation is dependent on, of course, how much power you get out at a given ambient temperature. In the Canadian climate, the 30 degree C or up to 40 degree C marks are the most important ones. So with the 185 or 255 kilowatt unit, you have full nameplate output power between that 860 and 1300 volt range we looked at earlier on the DC input. That can go up to then 185 or 255 kilowatts. The unit will derate thermally if the ambient temperature goes beyond 30 degree level. So you see the 40 degree line, which is then going down to 170 kilowatt for that 185 kilowatt unit at 40C. The 40C mark has plenty capacity for pretty much all installations in Canada. And you only have a derating when it really has the 40 degree ambient temperature. So there's a lot of headroom in there, but it's not a unit like in the past with another Chinese manufacturer where you had full nameplate output power, even with a connection cool system up to 60 degrees. That is not happening with these high power, high density units you see here. The low temperature performance, specifically for an installation in Canada, is very important. You can install the inverter in climates down to -40 degrees C, so pretty much most installation locations in Canada. The inverter, however, will not operate between -40 and -25. Only when the internal temperature of the inverter goes above -25, the inverter will actually connect to the grid and start producing. So CSI allows the installation. There is a warranty statement that you do not void your warranty if you install it, but do not expect output power of the unit if you are at record low temperatures at that minus 40 point, for example. Next slide. The inverter is fully NEMA 4X rated, and due to the fact that's a high-powered unit that is fan assisted, so there are multiple fans on the bottom that force the air through the heatsink in case the unit is at high power and the ambient temperature is high, that you assist the system to cool itself. That has then certain criteria how you install the system. CSI, since this installation manual is a North American-wide installation manual, recommends that you install the inverter protected from additional heat sources. So for example, if you're in Arizona or California, where you already have very high ambient temperature, if you would install it in such a climate without additional shade cover, it would derate further based on the direct sun exposure. In the Canadian climate, that is not really a problem. So even if there is still a recommendation from CSI to do that, to have the best performance, most installation do not need that additional shade cover. The same applies from a rain perspective. It's always good, like for any other inverter manufacturer, to protect your inverter, but the inverter itself would be fine if you place it right on your roof, just on a unistrat racking, for example, without an additional shade or rain cover on it. The distance between the inverters should be, according to the manual, 32 inches. And it's recommended, since the exhaust from the heatsink is towards the top of the inverter, that you have at least 2-foot clearance above the inverter, that the hot air can be dissipated and, yeah, exhausted on top. Certification, as I mentioned earlier, is super important because we're in a time right now where the old code is slightly shifting. New requirements come into the industry where utility companies want to use more of the features, specifically with a higher penetration of distributed generation in the field. The first certification listed here is the old-fashioned CSA 22.2 1071, and the inverter is listed to that. However, most utility companies nowadays request further certification that are more towards the smart grid features, and I have a special slide for that. Very common these days for pretty much all the inverters that are sold in the market today is the UL 7041 SA, so supplement A, with the grid codes, the underlying grid codes, IEEE 1547, and the unit is pretty much compatible to and certified to all of them, including the Rule 21 that is mainly applicable in California. Some jurisdictions in Canada also rely on features that are covered in Rule 21. But the big change now in the industry is the certification to the newest UL 1741 SB, so the Supplement B certification. The IEEE grid code 1547 in the 2018 version, and nowadays also the 2022 version is what, for example, utility companies in Alberta and Western Canada are already requiring, versus looking towards Ontario in the east. It's not as strict right now, but we also see, for example, Hydro One requiring more and more details on what additional features the inverter can provide to the grid. The system under UL 1741 SB is also implemented with the new communication protocol for an integrated SCADA system that none of the utility companies really have implemented today, but a lot of them want to be compatible to future implementation that the inverter system already supports, that bidirectional communication for commands to the system by the utility operator. The system, as Danny mentioned, is also AFCI certified to UL 1699B. A lot of people don't know what UL 1699B means. That's just a certification that covers the serious arc fault and all the reliability testing. But arc fault detection is what you typically are required to have if your installation goes on rooftop installation. The inverter here at the 600 volt level is one of the two products in the market here in Canada that has both the high voltage 1500 volt input, 600 volt native output voltage, as well as the required AFCI built in. And then a smaller certification, it's also compliant with IEEE 1519, which is the harmonics testing of the inverter. All the testing was done by CSA, so it's very easy to get your system through inspection.
And many of you may know this already, but one of the reasons we don't see too many 600 volt AC inverters that have that are in the Canadian market with AFCI is because in the United States you're not allowed to do 1500 volt DC on rooftop, and typically 600 volt AC inverters go hand in hand with 1500 volt DC. So that's why there's few and far between of those inverters out there. And this is, like Alex said, there's this inverter and Solus, which is the same, basically the same product anyways. So there is not much out there. There's one other brand out there we've looked into in the past and didn't really suit the market because it was a very old design and had single MPPT, and just there's a lot of question marks that came with it, and we decided against carrying it. Again, trying to go back and, those of you that have worked with us in the past on commercial string inverters, is we really do our due diligence and try to pick the right product for this market. Alex, did you see Dave's question there as well?
We will cover that later when we go to the rapid shutdown and how we can use it in different applications. Next slide.
Okay. This in regards to transformer.
Yeah.
Okay.
I was talking about some of the smart features the SA certification as well as the SB certification brings to the market. A few of them are here on that slide. The easiest one, of course, is a fixed power factor. Pretty much most inverters can already do that. Newer requirements are the Q of V, so the volt bar function, that if the voltage goes higher, the inverter is providing reactive power to the grid in order to maintain the voltage level. We also have volt watt functions, so P of V functions, which means that if the voltage goes too high, the inverter is actively reducing the output power to also maintain voltage stability. We have the same thing on the frequency side of things. So if the frequency is too high, instead of cutting off the inverter at 60.2, which was the old Canadian grid code, the inverter is now staying on the grid, but it's reducing its output power. So the risk to the grid by having significant capacity that is in distributed generation being cut off at one threshold is significantly eliminated by having a smooth reduction in power, and the inverter stays longer. The same applies to that fault right through. We have that for the voltage as well as for the frequency, where the inverter is just staying longer on the grid to provide short circuit current to clear that fault. And that's also a requirement for, again, more distributed generation being part of the grid compared to what it was 5 or even 10 years ago, that the utility companies have more assets to eliminate those faults and not have these hard cutoffs. There are a few more features, of course. I just picked the main features that are a little bit easier to explain, but these are the core features that are already in amongst others. When it comes to monitoring, there are quite a few options available with the inverter. Going to the bottom run right away, you can have a conventional old-fashioned RS485 daisy chain from one inverter to the other. It's a very reliable two-wire twisted pair communication, and you can use that, for example, with any third-party monitoring. The communication on the Modbus RTU is SunSpec compliant, so any third-party manufacturer for monitoring systems can use that protocol and can be implemented with that CSI inverter. The wiring from a hardware perspective is very, very simple. There are two connectors on the bottom. Both have the very popular M12 connector. So you have your whatever Cat5 or another communication wire. You connect that with that sealed NEMA 4X connector, and you literally just plug it in on the bottom for the in and the output. So this is how you then do your daisy chain. When it comes to a direct connection to the CSI Cloud Pro portal, you have two options. You can have a wired option with an Ethernet protocol, that's the Ethernet stick, or you can have a wireless solution with the Wi-Fi dongle that also plugs into the inverter. It's very simple because the inverter itself is powering that stick. So besides the Wi-Fi stick, there's nothing else you need to do. You need to, of course, configure the Wi-Fi stick. In case of the Ethernet stick, you need to run an Ethernet cable to that inverter location and then run it to a switch on your roof or in a monitoring cabinet.
Any recommendation? Any recommendation between either?
It really depends on how the system is set up. The RS-485, if you already use a third-party monitoring, then you can certainly use that. If you want to use the monitoring platform from CSI, which is quite powerful, and we will have a separate webinar about that, all the features, then you need to have one of those two first options, the Ethernet stick or the Wi-Fi, because that is the gateway that relays all the information from the inverter to the portal and also executes commands that you are sending from the online portal to the inverter if you want to use, for example, IV curve tracing and parameter settings, firmware updates, and whatnot. Next page. Very important on the commercial scale specifically that the inverter and the manufacturer of the inverter has all their ducks in a row when it comes to certification, data sheets, manuals, warranty statements, but specifically when it comes to the engineering company you're using, that they have all the documentation they need when it comes to applications and connection impact assessments. For example, short circuit current contribution, the impedance or sequence data. If the utility company for large projects want to do simulations, that there is a PSSE or PSCAT model available. OND files for simulation of the system, the temperature performance characteristic, the exact fault right through performance, IEEE 1547 trip data for all the different options, voltage derating, the protection philosophy, and other things like, for example, the mechanical impact. If you want to do drawings, how the system or how the unit is installed on your ground mount rack, for example, or on a Unistrut roof assembly, you can also get DWG CAD files where then your team can simulate that and model that in CAD. So we have all that documentation ready, that it's as simple as possible to have that documentation handed over to the engineering company and then subsequently to the utility company for approval.
Yeah, and this is like a list of documentation we've kind of compiled over the years from our experience with other manufacturers where we've brought their product to the market and kind of had to learn, right, at one point, you know, what are all the documents that are needed. And because of our experience, we do have the knowledge and we went ahead and requested all these documents from CSI right away as soon as we started the partnership last year, and it's pretty much all there. If there's anything else additional, then of course we'd be surprised if there's something we don't have, but if there is, we can definitely also get that. But yeah,
exactly, it's the data package for easy use of the product that you don't have to run after the manufacturer and pull that all together. That's really to simplify the use of that product.
Dylan is asking about Ethernet connection with the third-party monitoring platform.
So at the moment, the stick is not certified for Modbus TCP according to Sunspec. So it's their own communication protocol to the CSI portal. There is something in the making, but that is not ready yet. And the stick as it is right now, no matter if it's Ethernet-based or Wi-Fi based, is not compatible with a third-party monitoring system that is building on the Modbus TCP protocol. So you would need to use a conventional RS-485 wiring for that system.
But you can technically have two platforms running simultaneously, right?
That's possible, exactly. So you can use the RS-485 for whatever monitoring system you want to use. And when it comes to the O&M side of things, you can use all the features from the CSI Cloud Pro portal, that you have the best of both worlds, the integration on one side for your, let's say, asset management, if you have a large number of systems in your portfolio, and you can use the features for your O&M team to troubleshoot the inverter and do resets and commands on the CSI integrated portal.
And that's definitely something we've seen from bigger developers that have a very large portfolio of a few hundred megawatts of assets in the field, and they're using anything or all kinds of different inverters from different manufacturers that are running technically on different platforms or monitoring platforms, and they like to use a third-party monitoring platform to kind of high level overseeing all the assets, and then if they notice that there's something wrong with a specific site or a specific inverter, they can then go in this case into the Canadian Solar platform and really troubleshoot in detail remotely before even going to site and find out what is wrong. Is there anything that can be reset and done remotely without having a truck run, or do we need to go and to an actual site and do something physically? But even going to site, it may actually reduce truck runs because you don't have to diagnose it at the site and have 2 truck runs. You can do it remotely, figure out what the problem is, either have a new inverter already with you if there's an inverter fault, or if it's something else, you already know what you need to do when you get to the site.
Exactly, Danny. Jumping right into maintenance. So the inverter is largely maintenance-free, as most other inverter or string inverters on the market these days. A general good thing is to keep your inverter, specifically the heatsink, clear of debris, which is most of the time the case anyways. There is a fan module, since it is a fan-assisted cooling system, that can be slid out. So in case there is a fan problem, you can actually replace it in the field with that module that can be bought. The fans are designed for 80,000 hours of runtime. So typically for a 20-year life expectancy of the inverter, the fans should not be the problem. But in case there is a problem, you can very easily replace that without taking the inverter off or even sending it in. What's very important, and that's what I recommend in general for aluminum connections on the AC output side, that you retalk those terminals according to your maintenance schedule you have for these sites, because that's typically a little bit a topic for aluminum connections, especially after the first, let's say, year when you have installed the system. Next one. Coming to rapid shutdown, and we can go back to also options, how that inverter can be used compared to other solutions that are on the market, predominantly for 80-volt solutions. So best practice for large commercial system is always to have the least amount of components in your system. What is not there in your system cannot break and cannot create any headaches. So from a reliability as well as from a cost perspective, if you can place the inverter in the field, pretty much adjacent to the array, then you are automatically compliant with 64118, because the control conductor is not leaving that 1 meter, because the inverter is right within that 1 meter parameter. And that's what we see for almost all of those large scale solutions, because it's the lowest cost, highest reliability, and least amount of headaches. There are, however, a lot of projects on the smaller scale, especially if the roof is very segmented, that you may have a very large array on the roof, but then you might have 2 or 3 or 4 strings that are not within the 1 meter or the overlapping 2 systems. Then we typically recommend that you have a so-called selective deployment of a rapid shutdown solution. And that's pretty much the best of both worlds, because you install the inverter in proximity in 1 meter from the biggest system on your roof. And therefore you have the majority of your panels without any panel level equipment. And you only deploy the rapid shutdown devices to the strings that are not adjacent to the inverter and compliant with the code requirements. And this way, you can still do it all with one inverter, but you only have the cost and the reliability components deployed for the small number of panels in those separate strings. The good news is the APS RSDS rapid shutdown devices are 1,500 volt CSA certified. And together with the commercial SunSpec transmitter Danny mentioned earlier, you can just run the strings that are separated and place that transmitter on the roof. And there are 2 options to initiate rapid shutdown. The most common one is that you interconnect it with your AC supply from your main distributed generation disconnect of the system, because once AC is removed, all the inverters are off anyways, and you also remove the power from the SunSpec transmitter. And once the power of the SunSpec transmitter is gone, the SunSpec transmitter stops operating, and the RSDS devices automatically go into rapid shutdown mode. So it's a very easy way of being compliant without additional buttons and switches and additional cables that you have to run. But you can certainly, if it's too far away or so, or if you have multiple switch requirements, some of the jurisdictions in Canada have that, you can also place a low voltage switch at different roof access points or accessible to firefighters or the utility company on the side of the building, or even interconnected with a fire alarm system of your building. So all these options are possible. It really depends on how you set up your system and what you want to do to keep the cost down to still be code compliant. And the last option, that's the most expensive and the most components on the roof, is always you can have every single panel equipped with a rapid shutdown solution and place the inverter wherever you want to place them. They can be on the roof, they can be in an electrical room that is dedicated, they can be outside on a wall of the building, because then you completely separate the DC array from the location where you finally want to place the inverters. That's maybe 1% or less of the system at that capacity, because it's a very, very high cost overhead. Coming back to Dave's question, how maybe solar edge system on the commercial scale can be replaced. That's exactly how you want to do it. That you don't have an optimizer for every panel. The first step would be, can you place the inverter on the roof? Yes or no? If you can, your best bet, lowest cost, highest reliability, and easiest installation, because you literally don't have any panel level components. If that's not possible because of optical reasons or no space or certain local requirements, then you can still do the last option, and it's still cost competitive or cheaper in most cases than a solar edge deployment, because it's a native 600 volt unit, and you do not require a step down transformer, which costs quite a bit of money and has long lead times these days, because the unit is already at 600 volt native as your building connection. Next.
Yeah, and in general, we don't recommend optimizers on a commercial system anyways. It's something we have said for many, many years. And yeah, so if you do want to use optimizers, you can use optimizers with this inverter too. They would work with Tigo optimizers, and while it would be really nice for us to sell some extra Tigo optimizers, we don't generally recommend it. Again, points of failure. An optimizer is not nearly as reliable as a rapid shutdown device. It does a lot more things, and there's a lot more points of failure in an optimizer versus a rapid shutdown, which is just a simple relay. So yeah, definitely not recommending any optimizers. In most scenarios, there may be some applications where it's required, but usually we don't recommend optimizers on commercial systems.
I've mentioned the CSI Cloud Pro platform. You see a screenshot on the bottom right. That is our test system we have installed on our warehouse roof right now. We will have a separate webinar because the features are plentiful, and we want to not cover that. We don't want to cover that today because we really want to deep dive in a separate webinar with that. But there are multiple functions available. I mentioned some of those earlier. Remote parameterization. You can do IV curve tracing, firmware updates. You can have string level monitoring. You can compare different systems with each other. There's a weather forecast built in. There's a reporting function that you can program with multiple different. There's a scheduling function where multiple people from the O&M team, for example, to a local electrician can use the portal. There's a comment function where you can assign tasks to systems. You may or may not use that, but it's available in that portal. And again, we want to do that in a separate webinar.
Okie dokie. Okay, we'll do this slide, and then we'll go back to some more questions afterwards. So there's just a little review of what we talked about, specifically about the 600 volt solution. So the small unit, the 125 kilowatt unit, has 9 MPPTs. The 185 has 12 MPPTs. It is 50 amp IESC rated per MPPT. So pretty much any module out there will work as far as your amperage is concerned. They're 600 volt AC. They are UL 1741 SB certified, which is becoming a bigger and bigger topic out there, specifically in Alberta right now. But we've had some people in Ontario already requested. And then also we got a customer in the Yukon also that had to have it. So it's becoming more and more of a topic. We will have string level monitoring with these inverters. So something that, we used to be a pipe dream back in the day, back in like 2012, 2013, string level monitoring. I remember selling projects back then and I was asked all the time about it. And it's just become pretty standard now for modern inverters to have this, but this inverter also has string level monitoring. You can do remote and local IV curve scan function, sorry. It has an integrated DC disconnect. It's convection cooled with fan assist, so reducing the amount of fan that's required because it is convection cooled. It has a lot of smart grid features. Then we have Type 2 surge protection, DC and AC side, and then there's a number of different monitoring options as well. Alex, I think Dave had a follow-up question on the transformer.
Certainly, yeah. So the main reason why you would use a step-down transformer from 600 to 480 is that you are compatible to the 480 volt native inverters that typically are designed for North American, US focused market. And the US pretty much is 480 as a standard voltage for commercial three-phase, versus Canada has a lot of 600 volt. Western Canada has some native 480 as well on the farming area. But using a common voltage that is already here always makes more sense than putting a transformer in between. That adds cost, efficiency loss, and
another thing to worry about too. Like we've had the owners of Frankensolar also owns some projects, and I know we just had a transformer failure there last year, and it cost, how much was it? Did it cost to replace, Alex? It was like $30,000 or something. It was quite a bit. So definitely always stuff to consider. The less components you can install, the better, right? That goes back to the optimizer thing and anything else, trying to minimize points of failure. Alex, there was a question from David about
insulation.
Insulation, yeah.
So yes, the answer is you can do that as long as you have the required 2-foot gap for the heat sink and the air to come out of the top of the unit. Since you have a meter, which is roughly 3 feet, you have plenty of space to the ceiling of that room for proper ventilation of that unit. That is possible.
And then Alex was asking if we install the inverter in an electrical room and use conduits for wiring method for the DC wiring, what is the best method of connecting to the MC4 connectors of the inverter?
Yeah, so with the inverter being a multi-MPP tracker concept where you typically land the strings directly on the inverter, so you're not using a combiner box anymore, you of course have a large number of conductors, typically an RPVU90, being routed to the inverter. So the first message is, if you can put them on the rooftop, that would be my first recommendation. If you cannot, then you can do the Y connectors, for example, to cut the number of conductors in half by pre-combining at least 2 strings for MPP tracker on the roof into a 2-conductor home run, positive and negative for each MPP tracker. You still have a large number of conductors down to your electrical room, but that's the best you can do with that multi-MPP tracker concept, if you have to place them in a separate location.
And you saw the other question from David, right? Or the other point there? Did you want to address that, or you want to take it offline with him?
That's not exactly how it works, Dave. We can certainly have a call. It's mainly voltage adjustments. Your phase angle is fixed by the grid. There's nothing the transformer is doing here. If you want to go into it, the arc fault detection and the active anti-islanding. Here we go. Some methods use a phase shift system where you manipulate the phase angle in order to detect an islanding situation, or better to say, the inverter tries to manipulate the phase angle, but that has nothing to do with the actual transformer and the selection of the transformer. It's just a software method to detect if the inverter is part of an islanding grid that is not connected to the public, much larger capacity grid at that point.
And then Bartek was asking about the CSI string sizing tool. No, I don't think there is. However, it is pretty straightforward as far as what can be done. I think it's, what did we say, 21 to like
most
yeah.
panels in the 72 cell sizing or equivalent 144 half cells is within that 22 to 26, depending on temperature of your system. So as I mentioned earlier in my sample design, 24, 25 panels is the most common we see for 1,500 volt string designs, no matter if it's a CSI inverter or one of the other 1,500 volt systems.
Yeah, and if you're not sure, by all means, reach out to whoever your account manager is. I think with you, Bartek, I think it's Michael. Feel free to reach out to him. He'll check in with Alex, and Alex has a little Excel sheet where he can just double check quickly depending on temperature, et cetera, et cetera. So
send us the module you want to use,
exactly.
and send us what you want to do, and we can quickly double check that for you and give you recommendations. If what you do is great, thumbs up, or if we would go with a different. Exactly. So very good question, Dave. From a code compliance perspective, there needs to be a disconnect means typically within sight of the inverter. And these inverters do not have an AC disconnect built in. The DC disconnects are built in like with most other inverters, but the AC disconnect would be, in case of a 125K unit, a 200 amp frame size, normal square D, ABB, whichever brand you want to use, a Siemens disconnect on the roof, or a 400 amp category if you have the 185 or the 255. The only inverter that has a AC disconnect that I'm aware of as a pure string inverter is the SMA Core 1 inverter. They have DC and AC switch built into the inverter. Exactly. Very good question, Alex. Most jurisdictions do not require for inaccessible rooftops a conduit box for the connections. So you run your conduit pretty much all the way below the inverter, and then the last foot or so will be the cable in free air. That's, I would say, for 98% of the jurisdictions, again, for commercial inaccessible rooftops. If you do have accessible rooftops, which is very rare, for example, there's a rooftop patio where people can drink their coffee, then you would need to make a sheet metal box to cover that inverter, or separate the inverter mechanically from being accessible to the public.
Okay, not sure if there's any more questions. Feel free to keep typing if you have questions. In the meantime, how can you contact us? So you can send us an email to sales@frankensolar.ca. You can call us at our office line at 289-276-5279. Of course, if you have an account manager you're working with, feel free to reach out to them or myself, and they would be happy to help out as well. And then if you want some more information about the inverter, you can find it on shop.frankensolar.ca. If you haven't used our online shop yet, if you log in, if you just go on there and you're not logged in, you will see MSRP pricing. So it'll look all very high on the pricing side. However, if you have an account with us, sign up. We will then change your pricing to reflect the pricing on the installer price list that you receive. And all the discounts get automatically applied as you fill your card up. And then also on there, of course, you'll have all your data sheets and installation manuals, warranty documents, etc. on there. Alex, looks like is there another question?
Exactly. Smart grid features, especially the UL7041SB, is a very, very big topic these days. And it takes time until utility companies, inspectors, engineers, and of course the installers know what is required for what application. And probably it takes a year or two, as always in the solar industry, until everyone knows exactly what is really required. And it's not a gray zone anymore as it is right now with constantly varying requirements. But yeah, SB is definitely coming. And the good news is the Dinglong Solis as well as the CSI similar unit or same unit are already UL 741 SB certified. So you're compliant with today's codes or codes that will be required in the short future.
So yeah, before we wrap up here, again, I mentioned it already once. If you want to have a more in-depth discussion again and have additional questions, please feel free to reach out. We'd be happy to talk to you in more detail. We'd also be happy to do a presentation like this for your team if you're looking at using this inverter. Absolutely, we do this all the time. It's what we're here for. We want to make sure this is, if this is the right product for you, then you need to know everything that, we have all the answers that you need. Alternatively, this goes for, if you're looking at other inverters from us, we'd be very happy to help out. Like I said at the beginning, we're pretty unbiased. At the end of the day, we do carry a number of different solutions. At the end of the day, what's important for us is that you have the right product, because that's what makes us successful long term, is giving you the support you need. So yeah, excuse me. Yeah, with that being said, if there's no further questions, please stick around here. I think Hazin is gonna put up the link to the, there you go, it's in the chat, to fill out the quick questionnaire. Really would appreciate the input if you have a minute or so to do that. And think next week we have a presentation on commercial flush mount with Schletter. We'd be very happy if you joined there again. They have a new product coming out that is going to reduce the amount of, it's going to reduce the cost of their solutions. So I'm very excited to talk about that. They have a wide variety of products from anything standing seam roof, trapezoidal sheet metal, shingle, anything you'd ever need, they have. So be very happy to talk about that next Thursday, 1 o'clock Eastern. I guess it would be 11 o'clock Mountain Time. So thank you very much. Appreciate it.
Thank you very much.